All right, we reached our final chapter, chapter 14. This section discusses the IT professional. So you've been learning a lot of technical skills, but this chapter just talks about putting them all together and adding on to that some professionalism skills. So we're going to look at communication skills and the IT professional, operational procedures, ethical and legal issues in the IT industry, and then call center technicians. Communication skills and the IT professional. When you are troubleshooting, you're dealing with, fixing these technical issues. The technical issue itself is only part of the process. The reason we're IT professionals is because we have to express professionalism, especially when dealing with customers or a client. And whether you're providing that support directly for like a paying customer, or if you're providing support for somebody within your organization, that person at that point where you're doing a service for them is still considered your customer, even if they work for the same company as you. So you have to show good customer service when you're working with that person. And you also have to help them out within that troubleshooting process, because that customer is the one who initially recognized the issue. So you need to be able to communicate with them effectively, because being able to communicate with them effectively is going to help you solve the problem faster. So you can do that by establishing a good rapport with the customer, by you staying calm and relaxed, and then that's going to help you be able to gather information from them so that you can get their problem fixed. If you are talking with the customer in person, then that customer is going to see your body language, right? So you don't have to say everything that you mean, because you have gestures, you have facial expressions, all of that stuff working in your favor. But if you're on a phone with a customer, then you have to be a little bit more explicit in the way that you say things. The tone of your voice matters more, even your inflection. So providing that type of support is going to be different in a face-to-face scenario than it might be on a phone. Customers can sense whether you're smiling on the phone based on your tone and the inflection. It's funny too, because if you literally smile, your tone and inflection will actually change. So let that come through when you're on the phone with the customer, because again, you want to build up that rapport with them. Many call center technicians will use a mirror at their desk to monitor their facial expression, because again, that directly influences the way that their voice comes through on the other end. Some kind of key rules for working with a customer. You want to know, you want to relate, you want to understand. By know, they mean a definition for that is call your customer by his or her first name. So you want to create some instant rapport with that person, address them by their name. Sir and ma'am is kind of formal. But if they allow it, they'll definitely allow Mr. or Mrs. such and such. But if they allow it, even by the first name basis, then you start to build a camaraderie with that person, and it makes it a little bit easier for them to communicate with you. So example they gave here is, if the customer tells you her name is Mrs. Johnson, then ask if that is what she prefers to be called. She might say, oh yeah, Mrs. Johnson is fine. Or she might say, oh, you call me Nancy. And then you say, okay, Nancy. We're going to be working, da, da, da. Now that person is becoming like, they're more comfortable with you. It's easier for them to communicate. Next, relate. Create a one-to-one connection between you and your customer. Example they gave here. Find something that you may have in common. Doesn't have anything to do with the technical stuff. If you hear a dog, be like, oh, I got a dog too. Now you got something in common. It humanizes you to the customer, and it again makes them more comfortable talking to you when they're dealing with a frustrating situation. And then understand. Determine your customer's level of knowledge about the computer to help best communicate with them. If the person is computer savvy, then you can communicate with them differently than if the person is very new to computers. They don't know nothing about computers. Then you should avoid using jargon. You should avoid being overly technical. You should make things as simple as possible. But on the flip side of that token, if they're using computer jargon and they're talking the talk, then speak to them on their level so they won't feel like you're demeaning them by asking them to do stuff that, or talking to them like they don't know what they're talking about. Use active listening. Active listening is basically using your words to acknowledge that you've heard what the person says. So, for example, if a customer says something, then you can acknowledge what they said by saying, "I understand," or "Yes, yeah, that does sound like you're not just sitting there quiet. You're actually showing that you've heard what they've said. One really good active listening technique is to repeat a line from what the person said while were having a conversation with you, because then it really shows that you were listening, because you were able to repeat back to them something they said. Like, "Yeah, I was having this issue, with my computer. I went on the system on a Wednesday and it froze up on me while I was trying to get on Netflix." "Oh, so you were trying to get on Netflix when it froze up?" Yeah, I was trying to get on Netflix when it froze up." So it's establishing, again, this rapport with them, because it's showing that, I'm really invested in what you're saying, so much so that I can repeat back to you parts of what you said. Don't don't interrupt the customer to ask questions or make a statement. Listen carefully when your customer is speaking, and then let them finish their thoughts. You're going to also use, and this is right from the troubleshooting methodology, you're going to use open-ended questions in order to pull more information out of the customer about, what's going on, why they're frustrated, this, that, and the third. You'll use closed-ended questions, though, to guide them to give you more information. So you got to use that combination of open-ended and closed-ended questions. Closed-ended means it's a simple yes or no answer. Open-ended allows them to elaborate. Using professional behavior with your customer. When you're dealing with customers, it's sometimes easier to explain what you should not do than go over a list of what you should do. The following list describes things that you should not do when talking to a customer. So one thing, don't minimize the customer's problem. To them is a big deal, or else they wouldn't be calling you, or you wouldn't be desk side with them. So don't minimize it. Try to avoid using jargon, abbreviation, acronym, slang, because they don't know that terminology necessarily. Again, I would say the caveat is if they start using it with you, then maybe you can feel comfortable using that terminology with them, just to show that you respect that they're maybe close to being on your level. So, but you got to kind of do a balancing act, because they might just know a few words here and there, and don't just go all in, because they might just be trying to show off for you. Still, try to avoid as much as you can using the technical talk. Speak to them like a regular human. Don't use a negative attitude or have a negative tone in your voice, because that's going to come through on the phone, and definitely if you're face to face, that's going to come through. It's going to be a turn off. Don't argue with the customer or become defensive. That's just bad customer service. You shouldn't be arguing with you, even if the customer is disrespectful. If you've ever worked in any customer service job, you know that you still have to maintain your professionalism, even when the customer is, acting crazy. Worst case scenario, the customer's acting too crazy, then you hand that off to maybe like a supervisor or something. But you never dip down to that level. Don't say culturally insensitive remarks. You don't know who the person on the other end is. You don't want to insult anybody's culture or religion or anything like that. So don't say dumb stuff out of your mouth. Do not disclose any experiences with your customers on social media. So you shouldn't be giving away information on social media anyway, regarding your organization, and that's going to include, interactions with your customers. Don't be judgmental or insulting, or call the customer names. So I mean, that's pretty straightforward. Avoid distractions and do not interrupt when talking with your customer. Don't take personal calls when talking to your customer. You're on the phone. You're on the phone, or you're face to face with your customer, and your phone rings. You're like, "Yeah, you stop telling me about your problem. Let me go answer my phone." Oh yeah, yeah. What you want for dinner, hun? No, no, don't do that. Uh, don't talk to coworkers about unrelated subjects when talking to a customer. Avoid unnecessary holds and abrupt holds. Don't transfer a call without explaining the purpose of the transfer or getting customer consent. And don't use negative remarks about other technicians to the customer. These are some call transfer behaviors, things that you should do, and some things not to do. When you're about to put a customer on hold, you could do things like you should do things like let them finish explaining their problem. Uh, Tell them that you have to put them on hold and explain why. Ask the customer for their permission. Do you mind if I put you on hold? When the customer says yeah, then again explain that I'll be back in a few minutes. So they have some type of expectation of time. I'll be back in a few minutes. I just want to check with one of our engineers, yada yada yada, to help resolve your issue. If I place them on hold, it takes too long. Then you're gonna get back on the call, check in on them like they've been on hold for like 5 minutes. But you still need more time. You come from off hold for a second, let them know what the delay is for, and then maybe ask them, do they want you to give them a call back, or ask them would they be mind holding some more. But you're just going to do a check-in, so they're not waiting there forever. And always thank the customer for their patience as you work on their problem. Don't interrupt the customer. Don't put the customer on hold without explanation. Don't put the customer on hold without the customer's consent. And assume that don't assume your time is more valuable than the customer's time. And then if you need to transfer the call, the same type of rules apply. You're going to do explanations. You're going to explain why. You're going to get their permission before you transfer. You're not going to interrupt them. You're not going to do any of that without explanation. You're not going to think that their time is less valuable than yours. To keep your customer call focused, a couple of different things that you can practice is the proper use of language. You want to be clear and avoid, again, any technical language that the customer might not understand. Listen and question. So you're going to listen to them, let them finish their thoughts or whatnot, and explain their part. But then you're going to use those open-ended and closed-ended questions to really pull out what the problem is. And then you're going to give feedback. Let the customer know that you understand the problem and develop a friendly, positive, conversational matter with them. Operational procedures. Documentation is super important when it comes to the operations of a call center or like in a professional IT setting. The purpose of the documentation that you create is going to be multifaceted. One is probably the main one is to create how-to docs so that somebody coming behind you or somebody who's less experienced than you has like a playbook to work from. They don't have to figure the stuff out for themselves. They have a sheet that they can go through to figure out how to do things like do software installations or adjust the configurations of different pieces of hardware. They'll have descriptions of what different things in your environment are used for. And all these things will be collected in manuals or sometimes what we call knowledge bases. Some of these things are already created, like you can go online and pull up software documentation, but then there are going to be some that you create in-house because they'll be for how your company specifically uses that software and hardware. You're also going to have your standard procedures and practices documented. Sometimes you hear them called SOPs, standard operating procedures, and that's how your company does certain things. How do we run backups at company XYZ? How do we set up user accounts? What do we do when somebody leaves a company? What's our steps for like off-boarding their accounts? So those will be the standard procedures for your organization. and they should be documented somewhere so that as a person starts working with your organization, uh, they can read through the documentation and see how you guys do things. Documentation also establishes rules and restrictions for the organization. We talked about policies before. All of those policies are considered part of your organization's documentation. The acceptable use policy, the internet policy, all that stuff is written down so that, again, somebody new to the organization can be made aware of it, and for people who have been in the organization, they can be reminded of it because it's in writing. The documentation reduces confusion and their time saving, because everything, again, is written down. There's no guesswork involved. Some of this documentation also is required for by the government or different industries in order to document your processes. That you might get audited, and part of the audit from the government or some industry regulating body might be to produce these documents so that they can see your processes, see the things that you're doing to keep whatever protected. And then when training new employees, I kind of alluded to this earlier, you're training new folks, having these training documents, documentation is super important, because again, it makes everything consistent. Or even with customers, you're informing customers, having a document to share with them. Let's say the customer, needs help with some very well-known issue, like if they're calling about something that routinely happens. Well, one thing that you can do to help the customer, besides immediately helping them with their issue, is provide them with a document for how to properly do whatever task they were trying to do in the future, so that way they don't mess it up. They can just read the document and follow the steps. In your IT department, you're going to have different types of documentation. You're going to have your policies. Those are those rules that come from higher ups that give you a broad overview of how different things, the rules and regulations for the organization. But then you're also going to have your operation and planning documents. Those are more step by step. So they take those policies and they show you how to step by step implement them. For example, let's say I have a disaster recovery policy, and the disaster recovery policy just kind of broadly talks about the procedures that we're going to do. Not so much the procedures, it's going to talk about the policy, about how we handle a disaster. We would then have a procedure document that breaks down step by step how all those things we talked about in the policy are going to play out. Your operational policies, again, your operational documents and planning documents, they're going to show you the day-to-day of how to do certain things. And the planning document, of course, is your plan for how things should run in the event that something happens. You'll also see project documentation. So these are documents that outline the progress of a project. Might have notes, might have flow charts, and team rosters and things like that to help you keep a project on track. Then you'll also have user documentation. This is what your end users use to help inform them on how to use a specific piece of hardware or a service or piece of software. So it's like your how-to guide. Your user documentation is like your how-to guide for how to do the day-to-day tasks or involved with using a certain technology. Mentioned before that some documentation might be for compliance purposes, maybe compliant to something the government puts in place or some type of industry organization puts in place. But compliance overall means that there's some type of requirement from some organization that says that you have to do X, Y, and Z in order to run your organization. And typically these regulatory compliances, they just like a policy, they not only set out or set up rules for you to follow, they also set up consequences for if you don't follow them. A lot of times that could be like heavy fines for organization. They might even be things like, jail time for, executives or whoever's involved in whoever's supposed to be making sure that that compliance is in place. So with these regulatory compliances, they could come down from the federal level, state, or even local government, or like I mentioned before, industry, and the ones that are related to keeping certain records. Those are the ones that are going to trigger certain documents to be created. You might have to document, your access controls, how people are accessing different systems on your network. That might have to be documented. You might have to document your acceptable use policy, or document your policy for handling credit card or personally identifiable information. Those need to be written documents, so that way, if you get audited, you're able to produce those documents to the organizations who are auditing you. Most organizations, in order to get ready for that audit or get ready for those compliance checks, they'll do what they call an internal audit. That's when they audit themselves to make sure that they have everything ready, just in case the regulatory body comes and does the real audit. If the real audit happens and you don't have things in order, then you've had a failure to comply with the law and regulation. And like I mentioned before, that can have a lot of major consequences. People are going to get fired. Some folks are going to get fined. People might go to jail. Another form of documentation is the change control. Most, I would say, medium to larger organizations will have some type of change control process in place. And the purpose of the change control is to make sure that no unauthorized changes are happening on or to systems or different things within your organization. The change control process involves getting the entire company involved. Not everybody in the company per se, but at least representatives from different divisions within the organization, because this basically acknowledges the fact that even though you might be changing, some IT system, the IT department is not the only one affected by that. Changing that IT system could affect the HR department. It could affect the management team. It could affect it could affect a whole bunch of other areas besides just IT. So in order to get that change through, it needs to be approved by a panel or a board of representatives from all of those different departments. We refer to them collectively as stakeholders. They have a stake in this change happening. So a lot of times the way change control works is there'll be like a weekly or bi-weekly meeting where all of these stakeholders that come together, and different organizations or different departments or whatever who need to make some type of change will present that change to the change board, and then the change board will weigh in. They'll say, okay, we're fine with that change, but another department might say, you know what, that change might mess up this that we're doing. And the benefit of that is you, as the IT department, you might not have known anything about that other thing that they had going on. So you thought you were just going to make a change, but you had no idea it was going to mess up something that another team was working on. But this gives you the opportunity to share that out with all of the other departments to make sure that you aren't creating an issue with the changes you need to make, and also to make sure that no one team is making decisions in a silo by themselves without, running it past everybody else. If you change in this scenario, all approved changes, everything that gets taken past the board gets approved. And this is kind of like a CYA move, cover your move. Because what happens is if that change got approved and then you implement it and then something goes wrong, people can't come back to you and say, oh, y'all messed everything up. why'd you do that? I was like, well, on such and such a date, everybody approved that we could do it. But again, a good change control is going to also have this section right here. See, right, it says back out or recovery. So hopefully going through this process has already given you a way. You've already planned out a way to roll back and recover if something does go wrong. You plan that out. And then hopefully your change board has, really asked you about that. If something goes wrong, how you going to get back to normal? Well, in our plan, we're going to do this, that, and the third in order to back out of it. Okay, I give it a green light then. So change control, really important process. Disaster recovery is the ability to overcome a disaster. A disaster is something, it can be man-made, it can be a natural disaster. But either way is an event that totally takes down your operation, whatever your business operation is. You can't continue doing business if there's a disaster. There's another plan that I'm not sure if they discuss here, but there's another plan called a business continuity plan. That is if you have an event, like an incident that diminishes your capability to do your business, but it doesn't totally, eliminate you. So, for example, COVID could be considered for some businesses an incident. Why? Because it diminished their capability of doing business. Say restaurants. They can't do business at full capacity because of COVID as an incident. Well, you can have that same type of thing happen in IT. There can be an IT incident that prevents the company from working at its full capacity, but they're not totally shut down. Versus a disaster. A disaster is like there was a flood and it knocked out, or there was a tornado and it knocked out all the power in the whole area. That's a disaster. You can't work because there's no electricity. So we're down. We're totally down. We can't do anything. So you want to be able to plan for that. You don't want to wait for a disaster to happen and then be running around trying to figure out what you're going to do to overcome it. You want to have already planned for that happening, and then you'll have some type of backup plan. What are we going to do when it happens? The services that you might need to be aware of or figure out how you're going to get back up and running following a disaster could include things like web services and internet connectivity, your data stores and your backup files, how you're going to get those back, directory and authentication servers, how you're going to make sure people can log back into your network if one of these man-made or natural disasters occur, database and application servers, and then telephone, email, and other types of communications. And then you also have to prioritize that. In your disaster recovery, you should prioritize which services need to come back up first, and which ones you think you can get back up the fastest. Because the goal here is to get back up and running as quickly as possible and get people back in the organization back to work. To prevent downtime and data loss during a disaster, there's a couple different backup strategies that you can use. You can use local backups or cloud backups. Cloud backups have some advantages. They both have advantages and disadvantages. The advantages of the cloud backups is they're reliable, because if you're using a cloud service provider like Amazon or Microsoft, they have these data centers all around the world. And even in the United States, they've got multiple data centers where your data is being backed up to. So you know that your data is going to be available. It's not like, it's in one place and that place has a fire. Now your data's gone. No, they've got your data backed up multiple places. Also, it's scalable. If you need more space to save more data, it's like the click of a button in the cloud to add more storage. You say, I need 300 more gigs. I need 1,000. I need another terabyte. Click. Now you've expanded your capabilities versus having to go out and buy that hardware and do all the things you need to do to set it up that you have to do on a local backup. And then accessibility. That's a huge one. The cloud is accessible from anywhere you got an internet connection. So you get your internet back up and running after a disaster, and then like in 2 seconds you can be have your cloud access to your cloud backup because you got an internet connection. Now you can log into your accounts. With some of the disadvantages, you have time to backing up because it's backing up via internet connection, and because your speeds are going to be limited. If there was a major disaster in your region or in your town or whatever, then that could present a problem with internet speeds, which then would make getting your backups downloaded slower, especially if you got a lot of data. And then discontinuation of different services could be an issue, and the pricing. So let's say you went with some rinky-dink little small cloud backup company. What if they go out of business? Your backups are gone. They're not gonna come back into business just to make sure you get your backups. So make sure you go with a major player if you're gonna like an Amazon or a Microsoft, where you're like 99% sure they're not going out of business no time soon. That way you can have access to your data. And then the increasing of price. So unlike your local backups where you pay for that equipment, that hard drives, whatever, you pay for them once and they're yours. With cloud, anything is a service, is a monthly service charge. So that you got to keep paying for it and paying for it month after month. So that's kind of a downside. Local backups, some advantages. Local, you have local control over your data and files. So with a cloud, you don't have full control over every little aspect. If you own the stuff, you got full control over it. It's accessible. You can get to it quickly because it's local. It's there. It's nearby. So you can get to that data quickly. And then the speed of the file restores is quick because, again, you don't have to necessarily go over a wide area network connection. You have that device right there, those drives right there in the office with you for you to restore data. No internet involved. The drawbacks or disadvantages are scalability. So if you want more hard drive space, you actually got to go buy it, and then you got to set it up and get it configured and everything. And then if you want more, you got to do that again. So it doesn't scale. It doesn't grow as fast as a cloud. And then another disadvantage is off-site storage requirements. So even though it's local, you can't keep it local. You have to store copies of it somewhere else, because let's say there's a fire in your building. If your main data and your backup data are in the same building and a fire happens, guess what? Both of them got destroyed. Now you don't have no backups. So you have to store one off-site, which means that there's going to be some lag time in getting those off-site backups back to you. So plan accordingly. Some elements of a disaster recovery plan are going to include these 5 major phases. First is a network design and recovery strategy. Then inventory and documentation. Third is going to be verification. Fourth, approval and implementation. And fifth, review. So in that first phase, let's see if they break it down here. I'll talk about it then. In that first phase, you got to do a survey of your network. Find all the documentation that you have, figure out what's critical on your network, and you're going to design what your strategy is going to look like to get that network back up and running in case there's a disaster. The next thing you're going to do is do a full inventory of all of the assets, or the critical assets at least, on your network, and then pull together any documentation that you can find, or create documentation on those critical assets. After you do that, you're going to verify whether or not the strategy that you have to protect that inventory is going to work. So you go through this verification process. It could be a formal one. It could be an informal one. But after it's verified, then you get some type of managerial approval, and then you'll start implementing that plan. And then once you got that plan implemented, you don't just say, okay, I'm done. You have to review that plan on a regular basis, because disaster recovery plans are living documents. They have to be updated. You're going to have new inventory. You might redesign parts of your network. So you have to readdress this on a regular basis to make sure that the plan still matches what your network looks like. All right, 14.3, ethical and legal considerations. Respect your customers. So this is dealing back with our customers. Respect them as well as their property. Computers and monitors are property, but property also includes any information or data that might be accessible. So you're going to have access to a lot of potentially personal data because you are going in somebody's computer. You'll be able to see their emails potentially. You might see their phone and contact lists, records that they have on their system, and even hard copies of files and stuff that they left on their desk. So you have to be a person of high integrity if you're going to be IT professional. And even as you move up the ladder, you'll have access to more and more data. So you have to, be, mindful of that. This isn't just because you have access to the data doesn't mean is your data is still somebody else's data, and you have to treat it as such. You have to respect it. Some of the data you might encounter is PII. PII, or personally identifiable information, can include names, like first maiden names, first name, last name, all that information, social security numbers, passport, driver's license, even financial information, or even personal characteristics like images and fingerprints and handwritten. Anything that uniquely identifies a person falls into that PII category. And you might encounter that, so you got to be careful on how you interact with that data. Payment card industry. This is a PCI or PIC is a organization that oversees. They're like an industry organization that oversees companies that handle credit card data. They have a set of requirements and laws requirements, industry requirements that govern how credit card data should be handled. And if you're going to be a credit card handler, then you have to adhere to those. Those are one of the compliances that you have to adhere to. PIC came out with a standard in 2005, and it was agreed on by the 5 major credit card companies like Visa and MasterCard and them. And it covered how to protect account numbers, expiration dates, and magnetic strips, and chip data from transactions around the globe. You can read more about it at that link. But that may be something that, as a IT professional, you need to be aware of if you're working on systems where they're collecting that type of data. PHI is similar to PII, but it's healthcare related, protected health information. So if you work in a hospital or a hospital system or in a doctor's office or something like that, you might encounter this type of information, patient information, their addresses, their charts. So all of that stuff is protected by federal law called HIPAA, the Health Information Portability and Accountability Act. If you were to violate, HIPAA by, improperly handling PHI, that could actually have legal consequences. So you need to be careful with that, be cognizant of that, and use high integrity. For legal considerations in IT, there are going to be different laws for different countries and even different jurisdictions. So within a country, there'll be different laws for how things are handled from state to state. But in general, these actions should be followed. The following actions are considered illegal. Making changes to system software or hardware without permission, illegal. Accessing a customer or coworker's accounts, private files, or emails without permission, illegal. Installing, copying, or sharing digital content that's copyrighted without permission is illegal, even if it's between states or other regions. Using a customer's company IT resource for commercial purposes. Not necessarily illegal, but probably doesn't fall in line with your company's um, acceptable use process, acceptable use policy. To make a customer's IT resources available to unauthorized users, that's more than likely illegal. Uh, to knowingly use a customer's company resources for illegal activities, criminal or illegal use is typically like pornography, pornography, obscenity, any of that stuff. Of course, is illegal. Piracy, all of that stuff, and then to share sensitive customer information, then not necessarily illegal and not necessarily a violation of policy, but that's something that you have to get permission to do. So if I need to, if you're an IT person and you need to share, some data in order to troubleshoot a certain issue, like you need to share somebody's address or phone number or whatever in order to fix an issue that they want you to fix, then you get their permission first, and then you provide that information to the third party. Some other ethical and legal considerations include licensing. So, in order to use software, you have to typically agree to some type of end user license agreement, which is going to be the rules for lawfully using a software. There also and these rules are different from software to software. There's different types of licenses. Some licenses are, only for are for enterprise use, means you can use them in a corporate environment. Some licenses are for non-commercial use, which means you're not allowed to use them in a corporate environment. If you want to use that software in a corporate environment, you got to buy the enterprise license. There's open source licensing, which means you're allowed to download and use the program and even modify the source code, but you can't then try to commercialize it. So that's like one of the rules for open source licensing. So that's what they mean here. If you use here they're saying if you use the software to make money, you must pay the commercial license. So that could be for open source, or that could be for software that has a free version and a paid version. If you're using a free version, they might let you use it like open source. But if you're trying to make money off of it, or if you're using the software in a corporate environment, then they might say you need to purchase a commercial license. In order to control access to that stuff, there's tools called digital rights management software, or DRM. And what a DRM software does is designed to prevent the illegal access to digital content and devices. All right. A legal tool that's becoming more common nowadays in our technological society is computer forensics. Computer forensics, like regular forensics, is that process of gathering data or gathering forensic artifacts, evidence from various computer systems or electronics that a person might have access to. So some places you might pull that data from are computer systems, networks, wireless communications, storage devices, and all of this stuff. And this could be for criminal or civil purposes. A lot of times you'll see it for criminal purposes during criminal investigations. The collection and analysis of data for this purpose is called digital forensics, or computer forensics rather. And the process of computer forensics encompasses both IT and law. So there's certain IT aspects of it, but there's also laws that IT person needs to be aware of that can potentially affect the way that they collect and store data in order to make it admissible in court. Because if they mishandle that data while they're collecting it or when they're storing it, then that evidence, those artifacts, may no longer be usable when, say, a case goes to trial. One thing that that forensics examiner needs to be aware of is the difference between different types of data. There's two basic types of data: persistent data and volatile data. Volatile means unstable, means it's changing, and persistent means that it's more stable. Uh, when you're collecting forensic information from a system, you always want to go after the volatile data first because it's not going to be around long. Information that's stored in RAM, in the cache, or in the cache memory, on a system, that's static RAM, registries, all of that stuff is volatile. Matter of fact, RAM is probably the most volatile because the minute you turn your computer off, all that information gets cleared out of it. So that data needs to be collected first and preserved in some way. And it normally needs to be captured before the computer is turned off because it'll get cleared the minute the system loses power. Your persistent data is going to be data like the data that's stored on your hard drive, or even like external storage devices like flash drives or optical drives, because that can be maintained even after the computer is turned off. So you got to prioritize the collection of data to get the volatile stuff first, and then you can get the persistent stuff later. You need to be aware of different types of cyber laws. Cyber law is a term that describes the international, regional, country, and state laws that affect computer security professionals. IT pros must be aware of cyber laws so that they can understand their responsibility and their liability for cyber crimes. And then cyber laws explain the circumstances under which data or evidence can be collected from computers, data storage devices, networks, and wireless communications. So there's going to be certain instances when maybe the cyber law trumps your customer being customer friendly, right? If a law enforcement agency says go into this system regardless of what the customer said, then the law enforcement agency trumps what that customer might want. So you have to be aware of that. All right, first response. This is a term related to cyber incident management. First response is a term used to describe the official procedures employed by those people who are qualified to collect evidence. So a device has been determined to be the source of evidence in some type of investigation. You're the first one to touch it. There's going to be first response procedures, things that you have to do in order to make sure that data is collected and preserved correctly. You might be the person who discovers that there's a legal computer on your network. You don't turn it off. You go after the volatile data first, and then you go after the static data. You might even check for the programs that are running on there, what network connections it has open, who's logged in. All of this data that you're collecting is going to help you determine a logical timeline for the security incident, and it may help you identify who's responsible for it. Before that even occurs, though, you should be familiar with what your company's policies are regarding cybercrime, because that's going to outline who you're supposed to call, what do you do next. All of those important details should be outlined in your policy, so you got to be familiar with it. Documentation, just like in your regular IT daily process, documentation is also important when it comes to dealing with legal issues in IT. If you discover some type of illegal activity on a computer or network which you're working, at a minimum, you need to document what you saw. What's the initial reason for you accessing that computer or network? When did it happen? The date and time. What peripherals are connected to the computer? What are the network connections? What's the physical area the computer was located in? What's the illegal stuff that you found on it? Was that illegal activity witnessed by you or somebody else? And then which procedures have you executed on the computer when in your gathering of evidence? What did you actually do on the system? And then last part of this section is chain of custody. Chain of custody is important to ensure the integrity of the data that you've collected. Every time those forensic artifacts that you've collected change hands, there needs to be some type of record of where it went and who handled it. A lot of times you'll have a document that has to be signed off on when that evidence changes hands, just so that if it ends up in court, there's a trail that proves that there was no time or no person who would have tampered with the evidence. Right. So that's what you're doing when you create that chain of custody. And that's really important for forensic evidence to make sure, again, that it can be viewed as reliable or valid if it needs to be used in court. All right, last section, call center technicians. A call center is an environment that's organized and professional for customer service reps, or not necessarily customer service. It could be like help desk is considered like customer service because you're serving a customer. You're just serving them with technical support. A tiered call center normally has at least 2 levels, sometimes 3. These levels will indicate what the technician is going to be doing to provide that customer service. If I'm in a 2-tiered help desk, the first tier is going to be my phone support. Somebody calls in with an issue. I go through steps on the phone with them to try to resolve that issue. If we can't get it fixed on the phone, then that issue gets escalated up to the second tier of the help desk. And those second tier is normally going to be some type of maybe like desk side support where somebody actually comes out and provides like hands-on support for you. Some organizations even have a third tier, which might be engineers, like maybe product engineers or like systems administrators, systems engineers, or it might just the third tier might just be the systems administration or the networking team. Because now at that level, you've ruled out the issue being something maybe on an individual person's computer. So we got to push it higher up the stack. But either way, whether you're on tier 1 or tier 2, there's going to be certain service level agreements or SLAs that you're trying to adhere to. Example of an SLA might be, resolving the user's problem within 24 hours. Resolving or escalating the user's problem within 24 hours. So that's an example of the level of service that you're saying that you're going to provide to your customer. And every tier of a call center is going to have its own SLA that they have to meet. Computers in a call center have support software that a technician can use to manage their job. So one call center tool that you'll probably encounter if you work a help desk is a tool to log and track incidents. Sometimes we call them ticketing tools. So you'll be able to launch a ticket that has a description of what the problem is, and then you'll use that and when it came in, who was the caller, and it records a bunch of information, and then you'll also use that tool to track your notes as you're working through that issue with the customer. And then if you need to hand it off, you can just hand off that electronic ticket to the next. Let's say it needs to get escalated to a tier 2. You can hand off that ticket to the tier 2 so that they can see the research that you've already done and pick up where you left off. And then they can make their notes and comments too. You record contact information in these tools. You'll need tools to do research and product information. That could be something as simple as internet access so you can do research, or if it's specific products that you support, you might have manuals and things for those. You'll need tools to run diagnostics. So there might be tools like, vulnerability scanners and maybe tools specific to a products that you're troubleshooting. They might have diagnostic tools you can use. You'll have a research you'll be able to research a knowledge base, either an external knowledge base, or in a lot of call centers, you have an internal knowledge base that has like problems and solutions that your organization frequently encounters. And you can go to that knowledge base and search for solutions that your coworkers might have came up with already for similar problems that you're trying to resolve. And then last, you'll have tools for collecting customer feedback, things like survey tools, SurveyMonkey, or Microsoft Forms, things like that to collect customer feedback. When you're as a call center technician, another thing that you'll need to do is be able to prioritize your work. Some organizations will already have priority maps for you, where they came up with the priorities based on certain characteristics of the call, or other times you might have to make that priority call yourself. Here's an example of one call center priority mappings. So for example, a user calls and they're totally down, which means that their equipment's not working at all. That pushes them to the top of the stack in priority. That's the most urgent because they can't do anything. They're totally dead in the water. The next one is a hardware issue. If there's one or more, this is when one or more of the company's computers is not functioning correctly. This is urgent. That's the second most critical issue. Software. If there's one or more of the company's computers where the software or operating system has errors, that's also a level 2 issue, a second level 2 priority issue. So it's urgent. Network is the same thing. Company has computers that can't connect to network, that's urgent. But if it's just an enhancement, like an upgrade, they're up and working, they're fine. They just want to take advantage of some new feature. They want a new piece of software installed. That's just an important thing that gets prioritized at the bottom of the stack. But again, this is just one example. There could be, all different types of prioritizations. Your level 1 technician responsibilities could include things like collecting, if I'm in a ticket, collecting the contact information from the user, because the level 1s are typically the ones who start the ticket off. So at a minimum, they're going to set the ticket up and hand it off to the next team member. So they're going to get that contact information. They're going to find out what the make and model of the computer are, what OS is running. Find out and they're going to ask some basic questions in troubleshooting the computer. So during that tier 1, that level 1 troubleshooting, they're answering if we're following our 6 steps of the troubleshooting policy, troubleshooting process. Your tier 1s are creating that list of probable causes, and they're asking about them. Is it plugged into the wall? Is it connected to the network? What application are you trying to run? Have you done anything different to your system? You installed anything new lately? And they're going to ask those open and close-ended questions. They're going to get a description of the problem, and then they may be even the ones to prioritize it. And if they can't solve it, then they'll hand it off to a tier 2. A tier 2 will typically inherit that ticket from a tier 1. So this is an example of the ticket already being set up. It's already got all this information in it from when the tier 1 collected it. It even has a problem description and solution. Now the tier 2 can read up on that and familiarize themselves with the issue, and then they can continue their troubleshooting from this jump off point. And that troubleshooting will be a little less scripted, because if you're a tier 2, you're a little bit more experienced. You're going to have to use your expertise that you've developed to, again, address, coming up with potential solutions, coming up with a test, implementing it, seeing if it works, getting it to work, then getting the customer to agree that it works, maybe by testing it, and then you finally close out the ticket by documenting how you resolve the issue. And in that way, if your tier 1s run into it again, guess what? They might not have to escalate it to you, because you already, informed them on how the issue should be fixed. So it might be something that they can walk a customer through now. It's been added to your knowledge base. Scripts are also really important for IT professionals. A script is a way of automating different routine tasks that your operating system for your operating system. And you can script with a bunch of different languages, but you can also script with command line commands. So we actually remember we in previous section we looked at Windows and Linux and Mac command line commands. Those same commands can be put together in a text file in order to produce a script that can automate something for you. That way you don't have to manually perform those tasks on a regular basis. You just create the script and then you schedule the script and then you set it and forget it. And there's all types of uses for scripts. You might use a script to automate backups for a computer. You might write a script that can run diagnostics on a system or collect certain information from a system. So there's lots of things you can use scripts for. These are two examples of scripts written in different languages. This is a script using the Windows command line, a command line script, and this is a bash script for a Linux system. One of the key characteristics for Windows scripts is if you don't want a black box to pop up on the screen and show everything that you put in your script, just echo it. You'll turn off this echo feature. Echo basically shows on the screen inside of that black command window whatever follows the word echo. So if echo was turned on, I would see on my screen my first batch script. It would echo it to the screen. And then this next part of the script says my host name is, and then I have a variable called computer name. In your operating system, there are some predefined variables. Variable meaning it can change. They're pre-created variables that hold specific information about your computer. One of those variables is called computer name. It holds the actual name of your computer. And then this last line says pause. So it runs all this stuff. It gets down to the end and it pauses the screen. This bash script, that very first line, they call it a shebang line. And this basically tells the Linux terminal that what you're looking at right now is a Linux script, a bash script. The next line, the echo does pretty much the same thing echo does in Windows. It shows that line of text on the screen. Makes the screen say my first batch script. Then in that second line, the echo does the same thing it does over here. It makes the screen say, it makes the message, my host name is, and then whatever the name of the computer is. There's a built-in variable in Linux as well called host name, and that shows the name of the computer. And then last here, sleep 2 pauses the screen the same way we pause. So you see that this is the same exact script. It's just using a different language to write it so that it can run on a Linux system versus running on a Windows system. But those are just two scripting languages. Some other scripting languages you might encounter are PowerShell. So you can write PowerShell scripts. You can write Visual Basic or VB scripts, Java scripts, and Python. You can use script in Python. When you're saving those files, though, I'm saving a batch script. The file extension matters because remember, a file extension tells the computer, the operating system, how to properly save that file or what programs rather to use to read that file. So when my operating system sees a .bat file extension, it knows that this is a Windows script. I need to use the command line to open this up. When it sees a .ps1, it says this is a PowerShell script. I need to use PowerShell to open this up. .sh tells your Linux computer this is a Linux shell script. .vbs, this is a Windows Visual Basic. .js, JavaScript, and .py is a Python script. Within those scripts, you're going to do documentation as well. Good programs, which scripts are just small programs, have notes in them. The way we add notes is going to depend on what script and language we use. If we want to add notes to a Windows script, then we'll start off that line where we're going to put the comment or the note. well, you started off with the word rem, like remember. So rem is how we do a comment in that in command line. A hashtag or a pound sign is how we do the comments in PowerShell and in Linux. A tick mark is how we do, or that like apostrophe is how we do a comment in Visual Basic script, VB script. Two / is how we do comments in JavaScript, and a pound sign again is how we do comments in Python. These are some of the basic commands that you'll use in Windows and Linux. We already looked at these or some of these in our previous section when we were looking at the operating systems. A couple that we didn't mention, or rather one that we didn't mention for Windows is this date command, but you can use that date command to show the current date and time. And then you can format the date and time in different ways. Same thing for Linux, that same command exists. And if you notice that most of the commands are pretty much the same, like cd is the same on both Linux and Windows, make directory, mkdir is the same, date's the same, copy is almost the same, it's just cp instead of the whole word copy. And then to clear the screen, cls is how we do it in batch, and the actual word clear is used in Linux. And then the major difference is when I'm listing out my directories, my folders and files, I use the dir or directory command in Windows, and I use the list or ls command in Linux. Talked about variables a second ago. Think of a variable like a placeholder, and that placeholder holds a value. Those values can be of different types. Some values are type int, means that they're integers, they're whole numbers. Some variables are type float, which means that they have decimal points, they're floating point numbers, they have decimals. I can have a char variable, which means it is a single character. String variable means it's multiple characters. Or bool or boolean variable means that it produces a true or false value. Some of these variables are made by you, the programmer, the coder. Some variables are built into the operating system, like the ones we just saw in the previous script, like the host name for Linux or computer name for Windows. Those built-in variables are what we refer to as environmental variables. They're pre-made into the operating system. In addition to variables, you can also have conditional statements, and they're symbols to represent different conditional, or rather, there are multiple ways to handle conditional statements. One of the common ways is to use the if-then statement. So, and if the condition is met in a certain way, then something happens. So if this is true, then do this. There's also one that says if then else, or if else. If this is true, then do this, or else do that. So again, these are doing Boolean conditional tests. It's trying to figure out if some condition is true or false. If the condition is true, it's going to do one thing. If the condition is false, it does something else. But like I said, if-then statement is the most common implementation of a conditional statement. When I'm doing my conditional test, though, I can use these different operators here to figure out if that conditional test should be true or false. One of the operators, and you can use these more operators for math too, but on a conditional test, if I see in batch a double equal signs, two equal signs, or the abbreviation EQU, or in PowerShell, if I have a -EQ, same thing for bash, or in Python, double equals, that means that the two things, the conditional test is if they're equal. If this is equal to that, then do this. Not equal in batch is a exclamation point equal sign, or PowerShell -NE, same thing for bash, and same thing for Python. So Python is mirroring Windows in a lot of instances. So this basically says if this is not equal to that, then do this, else do something else. There's no less than for batch. In PowerShell is -LT, same thing in Bash, and then the less than symbol in Python. So if this is less than that, then do this. Greater than is the greater than symbol in batch and PowerShell -GT, same thing in Bash. Greater than symbol in Python. If this is greater than that, then do this. Less than or equal to and greater than or equal to work just like their counterparts. The only difference is that the value on the left side is included. So for example, if I said if one is greater than one, then do this, then that would evaluate to false because one is not greater than one. So my condition would fail, and whatever program I had running wouldn't run. Whatever task I had planned on running wouldn't work because one is not greater than one. However, if I said if one is greater than or equal to one, then that would evaluate the true because why? One is equal to one. I said greater than or equal. So therefore that would evaluate the true and it would let that program run. So it seems minor, but depending on how you use those, it could cause your conditional statement to not run or to run. So you got to pick and choose how you want to implement that. Besides the conditional statement, you also have loops. Loops are basically a reoccurring pattern that keeps going again until some condition is met. So an example of a loop is one example of a loop is a for loop. A for loop will continue to perform some task until a certain predefined condition is met. A common way to implement a for loop is with to have a cutoff number, and you iterate through that until you get to that cutoff number. So I'll say, do this until the counter reaches 5. So it'll loop once, and at the end of that loop, it adds 1 to the counter. It'll do it again, adds another to the counter, and after it does it, gets to the 5th time, and now the counter set to 5, the loop stops because it's only going to do it for a certain amount of times. There's also a while loop. The while loop will continue until some condition is met. So I can say, do this while, perform this activity while the number is greater than 8. So this might be another one that you step through, use a counter to iterate through, or it could be you continue this loop until some random condition is met. So maybe people are putting 8 the numbers in. So ask the person for a number. Maybe that's the thing. Ask the person for a number, and then until the number is 8, keep asking them for a number. So they type in 5. The script asks them for another number. They type in 3, and it keeps asking them for a number, but then they type in 8, and then the script stops because why? That while loop condition has been met now. And then the last one, do while loop. This one is like the reverse of the while loop. As long as the condition is already met, the loop will keep going. The minute the condition is not met, that's when the loop stops. So as long as it's Tuesday, keep running the loop. So when it turns Wednesday, the loop stops. And that is it for chapter 14. All right.